Good morning, everyone. Once again, welcome back to Jagadish College of Science. This video is from Mathematics Department, and I am your Mathematics lecturer, Jagadish. Okay, you guys already know we started your BSc 5.2 Laplace transformation classes, and in last class we discussed about your property number 5, that is Laplace transformation of derivative property. Okay, so today I am going to take your next property, that is property number 6, Laplace transformation of integral property. Okay. Okay. In last class, we discussed about your property number 5, that is Laplace transformation of derivative Laplace transform of derivative property. Okay. And the statement is if Laplace transformation of f of t, okay, if Laplace transformation of f of t is equals to f of s, then this is common for all. Then Laplace transformation of f dash of t, okay, this is derivative property, is equals to s into Laplace transformation of f of t minus f of 0. Okay, we already solved and we already see this property. So this is the first derivative, that is 5.1, and in that same property, that is 5.2, double derivative property, that is Laplace transformation of f double dash of t is equals to s square Laplace transformation of f of t minus s into f of 0 minus f dash of 0. Okay, so this is your second derivative. So like this, your 5.3, that is Laplace transformation of triple dash of t, that is the triple derivative, is equals to s cube Laplace transformation of f of t minus s square f of 0 minus s into f dash of 0 minus f double dash of 0. Okay, so this is your triple dash, the third derivative. Like this, when we take your Laplace transformation of nth term of derivative, okay, nth term of derivative, the formula is same as s to the power n Laplace transformation of f of t, and here s to the power n minus 1 f of 0 minus s to the power n minus 2 f dash of 0, like this up to s to the power 0, or you can erase it. Uh, it is f to the power n minus 1 of 0. Okay, so here we see this is third derivative, and here s cube, s square, s1, s0 is there. So like this, here n term is there, n minus 1, n minus 2, up to n minus n. Okay, so this is your fifth property, and write this carefully. That is nth term Laplace transformation of f to the power n t is equals to s to the power n Laplace transformation of f of t minus s to the power n minus 1 f of 0 minus s to the power n minus 2 f dash of 0 up to f to the power n minus 1 of 0. Okay, so this is your fifth property. So today I am going to take your property number 6, that is Laplace transformation of integral property. Integral property. Okay, Laplace transformation of integral property. And the statement is if Laplace transformation of f of t is equals to f of s, then Laplace transformation of integral over 0 to t. Okay, listen here carefully. f of u into du is equals to 1 by s into f of s. Okay, so carefully here, there is no difference between f of t and f of u here. Just instead of writing f of u, they will write f of u. Okay, don't get confused here. Okay. Okay, this is your property number 6. Property number 6, that is Laplace transformation of integral property. Okay, so the statement is if Laplace transformation of f of t is equals to f of s, okay, f of s, then Laplace transformation of integral over 0 to t f of u du is equals to 1 by s f of s. Okay, taking this one, we have to prove this function. Okay, let me prove. First, we will take, let this function, it is integral over 0 to t f of u du is equals to phi of t. Okay, call this as equation 1. First, we have to take, okay, let me take integral over 0 to t f of u into du is equals to phi of t. Okay, first we will take this function. Instead of writing this function, we will write this one. That's why we will take this one as equation number 1. Okay, on differentiating this function, okay, on differentiating this function, we will get, okay, on differentiating this function, we will get this function and this function will get cancelled. We will get only f of t, okay, and here phi dash of t. Okay, this function will be derivative. On that time we will get f dash of t. Okay, and also we will get f of phi of 0 is equals to, okay. So phi of 0, if you take phi of 0 means you will write 0 to 0 f of u into d. Okay, this is one function also 0. Okay, when we take the lower limit and upper limit both as 0, then the resultant will automatically get 0 only. Okay, we call this as equation number 3. Okay, now we consider the Laplace transformation of this derivative property. Okay, it is Laplace transformation of phi dash of t. Okay, phi dash of t, Laplace transformation of phi dash t. Okay, we already know this is property number 5.1 statement. It is Laplace transformation of f dash of t is equals to s into Laplace transformation of f of t minus f of 0. Okay, this is your property number 5.1. So using this property, we will write this function, that is Laplace transformation of phi dash of t is there. So here we will write s into Laplace transformation of phi of t minus phi of 0. Okay, so here we have f of t function there, and here we have phi of t. Okay, so that's why we will write this function as Laplace transformation of phi of t is equals to s into Laplace transformation of phi of t minus phi of 0. This is your property number 5.1. Okay, so this phi of 0 will get constant, the 0 term, so we will neglect. And this function we will write as it is, that is uh, Laplace transformation of s into Laplace transformation of phi of t. Okay, by your equation number 3 here. And here, okay, this function we will write as it is Laplace transformation of phi of t is equals to s into Laplace transformation of phi of t. Okay, okay, this is your same function, that is Laplace transformation of phi dash of t is equals to s into Laplace transformation of phi of t. Okay, we will take this s function to here. We will get 1 divided by s into Laplace transformation of phi dash of t is equals to Laplace transformation of phi of t. Okay, and this function we will write as cos, and this Laplace transformation of phi of t is equals to 1 by s into Laplace transformation of phi dash of t. Okay, and you guys already know, according to your definition, that is Laplace transformation of f of t. Okay, Laplace transformation of phi of t. This function phi of t we will take in equation number 1, that is integral over 0 to t f of u du. Okay, so here instead of writing phi of t, we will write here integral over 0 to t f of u into du, and this remaining function as it is. That is 1 by s into Laplace transformation of this function. Okay, we will write as phi of t by the equation number 2, and this function is by equation number 1. Okay, so we will write this function as Laplace transformation of integral over 0 to t f of u du is equals to 1 by s into Laplace transformation of f of t by your equation number 1 and 2. Okay, so here this is your here this will get your resultant answer, that is Laplace transformation of integral over 0 to t f of u du is equals to 1 by s into f of s. Okay, it is resultant final answer is, that is Laplace transformation of integral over 0 to t f of u du is equals to 1 by s into f of s, or we will write it is as 1 by s into Laplace transformation of f of t. Okay, so don't get confused here. So we will write here, that is clearly your Laplace transformation of integral over 0 to t f of t dt is equals to this function f of u. Instead of writing f of u, we will write here f of t. This is your common function, and remaining as it is 1 divided by s into f of s is equals to 1 f of s, this function, or we will write this function as 1 by s into Laplace transformation of f of t. This property means, that is wherever you will get 0 to integral over 0 to t f of t function. Okay, instead of writing this function, your formula is 1 by s into your remaining Laplace transformation of f of t. Okay, this one is simple property. You have to practice this two to three times. Okay. Okay, we will see some examples on this property. On that, you will get clearly. Find the Laplace transformation of 0 to integral over 0 to t sin t by dt. Okay, this means whenever you get 0 to t integral over 0 to t function, on that time you will take 1 by s into this function sin t. Don't take this one, I take this one, giving one example for this. That is integral over 0 to t sin t, only sin t. This becomes your sin t. Laplace transformation of sin t is a divided by s square plus a square is there, and here a value is 1. That means 1 divided by s square plus 1 square. So here this function, integral function, we will write as 1 divided by s into this one is 1 by s as it is according to your definition of integral property, 1 by s into, and this is your Laplace transformation of remaining sin t function. This is 1 divided by s square plus a square. A square means 1. That is s square plus 1. Okay. So now here we will solve this function. One problem, one example here. That is find the Laplace transformation of integral over 0 to t sin t into dt. Okay. Solution. First I will write the given equation, that is Laplace transformation of 0 to t sin t by t into dt as it is. Okay, and we know that your property number 6, that is integral over Laplace transformation of integral property. According to your definition of Laplace transformation of integral property, Laplace transformation of integral over 0 to t f of t dt is equals to 1 by s into Laplace transformation of f of t. Okay, so here this is your given function. Instead of writing this function, we will write directly this one. That is, Laplace transformation of given function is integral over 0 to t sin t by t dt is equals to 1 by s as it is, and this is your remaining function, that is Laplace transformation of sin t by t. Okay, by your property number 6. And this function we will write here, it is 1 by s into Laplace transformation of sin t by t. Okay, call this as equation number 1. Okay, call this as equation number 1. Now we have to prove your this property. It is Laplace transformation of sin t by t. Okay, 1 by s is your constant term, keep it as outside as it is, and remaining this function we will get Laplace transformation of sin t by t. Okay, is equals to integral over s to infinity Laplace transformation of t. Okay, so this is your property number 4, that is Laplace transformation of f of t by t is there. On this time we will write your integral over 0 to infinity and remaining Laplace transformation of f of t into ds. Okay, this is your property number 4 statement. So using this property we will solve this function, that is Laplace transformation of sin t divided by t. So we will write integral over s to infinity Laplace transformation of sin t into ds. Okay, so here your statement is there, that is property number 4, and this function we will write as it is Laplace transformation of sin t by t is equals to integral over s to infinity and your remaining Laplace transformation of sin t into ds as it is. Okay, so here we will write our same function, that is Laplace transformation of sin t by t is equals to integral over s to infinity and remaining Laplace transformation of only sin t. Okay, and you guys already know sin 80 formula. Sin 80 is equals to a divided by s square plus a square. So here your a value is 1. It is 1 divided by s square plus 1 square. Okay, so instead of this function we will write directly this one. It is integral over 0 to infinity as it is, and Laplace transformation of sin t value is 1 divided by s square plus 1 to ds with respect to ds as it is. Okay, so I will write this one once again, that is Laplace transformation of the sin of 80 we will get integral over 0 to a infinity, integral over s to infinity 1 divided by s square plus 1 into ds. Okay, when we integrate this function with respect to s, we will get 1 divided by s square plus 1 is formula, that is your tan inverse of s, and your limit is s tends to, and your limit is s to infinity. Okay, your upper limit is infinity, lower limit is s, and this function I will write here, that is tan inverse of s, your limit is s into s to infinity. Okay, when we apply your limits, that is upper limit minus lower limit, we will get tan inverse of infinity minus tan inverse of s. Upper limit is infinity, lower limit is s, and tan inverse of infinity will get pi by 2 and remaining tan inverse of s as it is, and pi minus theta, that is tan inverse of pi by 2 minus tan inverse of s is equals to your cot inverse of s. Okay, and from your equation number 1 we have 1 by s into Laplace transformation of sin t by t, and this is your equation number 1. 1 by s is as it is, and this we call with this we now solved, and this way we will get cot inverse of s. Okay, so here we will write from your equation number 1 by s into cot inverse of Yes, we will get. And your final resultant answer is, it is Laplace transformation of integral over 0 to t sin t by t into dt is equals to 1 by s into cot inverse of s. Okay. And I will give some examples and some problems and sorry some homework for you. Try to solve yourself and send me the answers through WhatsApp. First, this function, that is 0 to integral over 0 to t cos t dt. So this function we will get according to your property number 6 definition, 1 by s into Laplace transformation of cos t, that is 1 by s into cos t your formula is s divided by s square plus a square is there. Okay, s will get cancelled and your answer is 1 divided by s square plus a square. You will get here this function, and this function is as it is. It is 1 by s into sin t by means a divided by s square plus a square. Okay, and here you will get property number 2, that is first shifting property, e to the power minus st here. That means 1 by s into Laplace transformation of f of t over s tends to s minus a here. Okay, so solve this function as be like this. This function as same here, and this function also same here. And this function is a multiplication property, that is minus 1 to the power n d to the power n divided by ds to the power n, and your remaining Laplace transformation of f of t. Okay, this is your derivative t to the power n property, and this integral property will write 1 by s as constant outside. Okay, so this property we just solved here. So you have to solve this one. Here we have hyperbolic function is there. This function is also okay. Try to solve this function. This for homework for you. Try to solve and send me through WhatsApp number. Okay. I hope you are getting this the all problems. Once again, I am telling the same. That is, if you have any doubt and any queries regarding to this class or in previous class, make a separate note for that. Take a picture of that problem and send me through your WhatsApp number. I will clear to that problem. Okay. Okay. Thank you. Thank you for all.